Hello and welcome everyone. Thanks for joining us for today's webinar, Behind the Buzzwords, Machine Learning and AI in Corporate Travel Management. A few housekeeping items before we get started. If you have any questions during the presentation, please type them into the question box in your GoToWebinar control panel. We'll answer as many as we can get to at the end of the presentation. Also, we are recording the presentation today and we will be sharing out the on-demand webinar to all attendees. I'm Heather Lohman, Senior Content Marketing Manager here at TripActions. And now without further ado, let me introduce our presenters, TripActions Co-Founder and CTO Ilan Twig and Head of Product Anique Drumright.
Thank you, Heather, and thanks everybody for joining us today. Just before we start, I'd like you all to think about how many times you ran into the terms like machine learning, AI, artificial intelligence, ML. We think the answer is a lot. And that's why we thought that spending the next 20-25 minutes talking about machine learning, AI would be actually really beneficial to all of you, interesting, and a good use of your time.
Yeah, so over the course of this webinar, we're going to explain what machine learning actually is, even though it seems to be everyone's favorite buzzword right now. And then we'll spend the second portion discussing how we use it in our business daily.
All right, so let's start with AI. So AI simply stands for artificial intelligence. And in order for us to understand what artificial intelligence means, let's start with talking about intelligence. So intelligence, in a simple one-sentence definition, is the ability of humans or just ability to understand and to learn and deal with a new situation. And then artificial intelligence is an attempt to create intelligence artificially. And more specifically, when it comes to computers, it's a software that attempts to mimic the human intelligence.
And machine learning is really one of the ways that you can achieve artificial intelligence. And machine learning utilizes statistical algorithms to mimic the human brain in machines.
All right, so let's talk about humans and machines. Start with machines. Machines, traditionally, they just follow instructions. And so when you go and get a new laptop or a new computer, you literally just get a box, and this box can't really do much. It's pretty much a dumb box. And if you want to benefit from it, you really need to have a developer or an engineer that will write software or an application to it. And with that, the computer, could start doing stuff like playing music, playing videos, rendering pictures, allowing you to browse the web and stuff like that. And this software, in essence, is just a set of instructions with conditions. So that's what machines traditionally do. In contrast, humans, in addition to be able to follow instructions, humans can learn. And the way humans learn is from experience. So the simplest example here would be you touch a hot stove. So when you touch a hot stove, it's your personal experience, and then you learn something from that. And you learn that it's something that you do not want to do again. But the nice thing about the experience part of it is that it doesn't necessarily have to be your own experience. So you could, for example, talk to a friend of yours that just happened to touch a hot stove. And he or she will tell you, hey, I just did that and it's horrible and I don't think you should do it. So there you go. You just learn from someone else's experience. And an even more extreme example around this hot stove would be if someone that you've never met in the other side of the globe that touched a hot stove and decided to write a blog about it, and you just happen to read that blog, you can learn from this person's experience without even meeting them, and gain some insights on a situation that you've never seen before and know what to do about it in the future. So really humans can learn from experience by reading, listening, observing, or just experiencing yourself.
So machine learning is really, instead of machines learning from experience, they're learning from data. With machine learning, data equals experience.
All right, so I think the best way to move forward is to talk about an example that will just show you, how does it really work? How do machines can learn? And in this example, let's pretend that we are a car insurance company, and what we're trying to achieve here is we want to personalize the policies that we provide for drivers based on how safe they are or how safe they drive. So in order to do that, we need prior data or prior experience. So what would be relevant here is, let's say, 100 drivers and everything about them, drivers and more. So drivers, it would be their profile, right? Their name and their gender, prior offenses, and prior violations, and everything about them, combined with the way they actually drive. So let's imagine that we have a black box that is recording everything that happens in the vehicle, including voice, as well as the behavior of the driver, the speed, and everything around the driving. So now, we have this table. Each row represents a different driver, and there is a lot of features. Some of them I just mentioned, but even like the number of times that they hit the brakes, the average speed, do they even use the signals, etc. So that's our experience. It's data that was recorded, and the one key feature that will allow us to assess or predict the safety of this driver is whether there was an accident or there was no accident. So now imagine the same table that we mentioned before with all these features, and there is one more column, accident ? And then yes, and some no, and some yes, and some no. So with this data set in mind, our machine learning algorithm, which Anique internally refers to as Look. So now Look tries to analyze the data and come up with insights and understandings. So let's take a simple example. Let's try to look for the average time on road and see how it relates to having accidents or no. So if we look on all the data, we might see that 25 drivers that spent more than 10 hours daily on the road had an accident. So what we need to do now is take a closer look on how it splits on our data set. And what we might see is something like that. So what we see is that 80% of the drivers that spend more than 10 hours on the road ended up having an accident. And that's the big 80% you see on the right side of the screen. So from that, Look can conclude the first rule. And this rule would be, driving for more than 10 hours daily, the likelihood of having a car accident is 80%. So Look goes ahead and starts to build this table of features and probability. The first one is what we just said. But Look continues to look for more correlations and insights. And for example, drivers that tend to have overnight drives, the likelihood of having a car accident is 70%. No driving license, 86%. If you have 17 prior violations, 99%, etc. And obviously this is a made-up example, but the idea is to explain how these self-teaching works.
And so this is our first learner, the naive Bayes algorithm. And what Luke is really doing here is taking a number of disparate insights, such as you've had 17 violations, or you've been driving for 12 hours between, midnight and 10 a.m. And he's using those disparate insights together for a more powerful insight, such as the likelihood to have an accident, yes or no. And so this is one learner, but there are many, and we'd like to take some time to kind of explore another learner, which is the decision tree, which is my personal favorite because it tells me what movie I'm going to watch on Netflix, or what music I'd like to listen to on Spotify. And the example that we're going to go through, or Ilan's going to share, is jobs you might be interested in.
Yeah, so in this example, let's imagine for a second that we are LinkedIn, or a site that deals with jobs and people. So what we would like to do here is leverage machine learning to provide or to recommend a job to a user, a job that might be relevant or might be interesting for this user. And obviously, different users would have different recommendations. Before we proceed with that, I do want to highlight that there are different learners when it comes to machine learning. The first one that we just talked about, the naive Bayes, is a classifier, and it helps classifying stuff. It can classify a driver as a risky driver or a safe driver. It can classify an email as a spam or non-spam. It can classify pictures as having apples there or not having apples, etc. What we're going to see here is something completely different. So that's the recommendation engine that Anique just mentioned. And the previous data, just like the previous example, it starts with previous data, previous experience, would be different users that came to our websites and what jobs they showed interest in. So for example, we can see that an engineer of the age of 22 expressed interest in an internship in engineering. And we can see that a finance person at the age of 55 expressed interest in CFO position. So what Look would start to do here, it will look for the best way to segment the data. So it will look for that feature between age and profession that best, dissects the data. Now, this is a highly, highly, highly simplified data set and example. Reality is way more complicated, but it essentially works exactly the same as what we're going to see here. And it's just a really simplified example just to send the point here. So let's see how it looks like. We look on the profession. You see the engineers, you see the finance people, but there is nothing really conclusive here. If you look on the age, you see that actually all those that are less than 25-year-old are interested in some sort of an internship role. So Look will find this feature that best dissects the data, and that would be the first junction or the first condition in the root of our decision tree. And it will look something like that. So it starts with an age. If the age is less than 25, they are definitely interested in some sort of an internship role. If it's above 40, we need to look on the data and see what the next feature is and how we can break the data. You will also notice that we have nothing between 25 and 40. So Look cannot conclude anything about those users between these ages because we don't have any prior data about it. In reality, obviously, we would have had, but for the sake of this example, you can see the importance between the data and how we learn. So let's look on the next feature and the data, how it looks like. So that's what we are left with. So when we look on the profession, we can clearly see that if it's an engineer, we should probably recommend a head of engineering or a VP role. And if it's finance, it would be a CFO. So we're going to go ahead and just add this junction to the tree. And now if the user is above 40 years old and is an engineer, we will recommend a VP or head of engineering. If it's a finance, we will recommend a CFO position.
So this is the decision tree, and what the decision tree does is it follows a chain of observations to get to a specific endpoint or a conclusion, which is why it's so often used for recommendations. And yeah, we use it all the time at TripActions, and various startups are all using the exact same learner to enhance their product. So in conclusion, how do machines learn from data? Machines learn from a set of defined statistical-based algorithms. The naive Bayes theory that we use at TripActions is no more special at Google or at Apple than it is here, and the same with the decision tree. And as Ilan and I were prepping for this webinar, what we really wanted to communicate is that the algorithms are finite. What is unique is the data that we provide and the feature sets that we define for the machine. That is what makes the insights and the conclusion unique. So I think the easiest way to really remember this is just to think of yourself. Think of your brain as your algorithm. Imagine growing up in California. The way that you process experiences and data would be exactly the same because it's your brain. What would make your insights and your learnings for life unique is the data that you would receive. If you take that same brain or that same algorithm and you move it to New Orleans, how you view life would be completely unique because the data and the experiences that you use to create conclusions and insights would be driven by that data. So for why, Ilan loves machine learning because he finds it fascinating. I love machine learning because I think it makes our product great. So machine learning in corporate travel, how are we using this daily at TripActions? I think to understand how we're using it daily at TripActions, you first have to understand how we think about our business. So we make a number of assumptions when we're developing products at TripActions. The first is when I'm traveling for business, it's about a single location. I need to have an in-person meeting or a conference. I'm not really flexible on location because I have a person to meet somewhere. The second assumption that we make is that booking travel is a means, not the goal. No one wants to spend forever booking travel. Therefore, the third is pretty obvious. It should be quick and it should be easy. And so at TripActions, we're using machine learning in a variety of ways. We use it to optimize inventory, to optimize pricing, to customize your search results, etc. It's why booking with us takes 6 minutes versus 20 on a traditional corporate travel site. But for the purpose of today's webinar, we're really going to focus on two things: if you'll book and what you'll book. Let's begin with if you'll book. Here I have an extremely sample feature set. You know it's sample because there's only 6 features here. On the left-hand column, I have 1 through 6. This represents my number of searches. At the very top, I have my quote-unquote feature set. So the feature set represents who is searching and what their results look like. So what's their age, what's their gender, how many results did they get, how many results did they get within their loyalty club, and then ultimately, did they book yes or no, because we're trying to predict if you'll book. From there, once Luke has absorbed the feature set, absorbed the data, he'll come up with a number of insights. And this is actually our real data. So the first, or one of the many insights he came up with was, the more you travel, the more likely you are to book. Another insight he came up with is you are more likely to book closer to the trip date, probably because there's a last minute meeting you have to go to.
What I just want to add here is that, these 2 examples might seem really, really obvious, right? Of course, if I travel a lot, then there is more likelihood that I will actually book. But reality would be way more complicated, and would actually look something like that, and way more complicated than that. So
yeah, this is a portion of the output.
This is just a portion of the real output. And what you can see here is, think about all the different features. Like, there's a lot of them. We mentioned just a few. But then Luke will go and try to correlate everything with anything, and we'll plug it into the model. And so it's the time that you spend even time that you spend looking on a specific flight, it would be an input. And what your colleagues have done would be an input. And your past booking would be an input. And everything would be an input. And Luke will come up with all of these correlations, and it would translate into this tree that ultimately, at the bottom of the tree, the leaves will say, will book or will not book. And just to not to confuse you, but to explain to you how really it happens in our system. In our system, there is a collection of trees, and they are all being merged together, and this algorithm is called a random forest. And the random forest is literally a collection of all of these trees. It's really complicated to the point that no humans can really come up with a model like that, but Luke can, and that's what makes machine learning so powerful, where everything is being taken into consideration, and the outcome is very accurate. We have the ability to predict whether you book or not with more than 90% accuracy.
Yeah, and I think the other thing that I'd want to add there is this is all being done instantaneously. So it's why a human can't do this, because I would have to think about one of these things one at a time, whereas Luke can do it all at once. And I think in terms of understanding what this does for our product experience, the easiest way is through this example of machine learning and our support team. So let's take some search data from a traveler. So here's a few things I know about a traveler. The traveler is an infrequent traveler. They've searched twice or more. They have one loyalty number. And then there's about 10 other features, tens of other features that Luke is looking at any point in the search. From there, he'll predict, or she will predict. We have not decided what
yet.
Luke is, that the traveler is 95% unlikely to book. And based upon the assumptions that Ilan and I shared previously, we know that this traveler needs to be somewhere. Therefore, we trigger a smart human intervention tailored to the user, because at that point, we know that the user is in trouble, however, has a place that they need to be. And then on the flip side, on the support side, we're also leveraging data and information to the travel agent about the user, about what we think they might book next, expediting that interaction. And before we move on to the next slide, I want to share one thing that I think is important to TripActions and how we think about machine learning. We are not using machine learning to replace humans or to replace the interaction between our support team and our traveler. We are choosing to use machine learning to customize our product for our travelers and to leverage that human interaction at the exact right point in time and in the way that a traveler needs it. So we've gotten really good at predicting if you'll book. The other thing that we spend a ton of time working on is predicting what you'll book, because again, we believe that booking should be almost instantaneous. And this is really what brings us into what we believe will be TripActions' future.
So very similarly to the way we talked about the previous examples, we also, based on previous data, we can very accurately predict what you'll book. And once we get to the point where we have more than 95% accuracy, we'll definitely get there. At that point, we can try to rethink how corporate travel should look like. And with the assumption that no one wakes up in the morning with the desire to go and book. The desire is, hey, I need to be in Amsterdam because I have a team meeting, or I need to be in Tokyo because I have a conference, or then really what we could do as a travel solution would be to just take care of your travel. So imagine a future where all you need to do is just provide us with where you need to be and when, and then we will take care for it for you. Now, sometimes things change, right? Actually, many times things change. You might change your plans, or plans might change on you, and then you need to respond. At that point, we will engage immediately with an agent, as Anique said. The agent will be powered with really smart tools, and Luke will be one of them. But then you can just take care of everything that is needed at that point. And then the third component would be just an itinerary, because we are used to having this view on what's coming up, what's coming next in the trip. So that's kind of what we are cooking.
Yeah. So Heather, I don't know if there's any questions that you're getting.
Yes, thank you so much, Ilan and Anique. We do have a couple of questions that we have some time to get to. First up, how does machine learning impact personalization?
So I think it's a good question. It's basically the essence of this presentation and webinar. And think about it this way: when we try to predict what you'll book, the way Luke does it, he basically gets the result. So let's say you're looking for a flight from San Francisco to Amsterdam. Then let's say that there is 200 flights. What Luke will try to do is rank them based on the likelihood for you to book them. And that's basically the answer to your question, is that will be the most highly personalized experience. It will be really, really sorted by how likely it is that you will book this flight.
Yeah, and we're also, like Luke's taking into consideration the policy, right? So if you're going to break the policy, then that hurts the ranking of that sort order. If it's within policy, like we know from data, the traveler is more likely to book that. No one wants to break rules. So I just want to clarify that we are taking into account data from the traveler side and their preferences as well as the policy, because we know both have an impact.
Yeah.
Can you talk about how this works with changing behavior? For example, an employee books 4 days out that you would want to book 14 days out.
So yeah, absolutely. So for that, it's actually the way that it's more a UI question, and what we try to do is the entire booking experience is really tailored for good behavior. And what we try to do is, let's say that there's a conference and there's like 10 people from the same company going to that place in Tokyo. All of your friends or colleagues have booked, 9 of them have booked 3 weeks in advance. And you now are booking, 4 days in advance. At that point, you obviously would still be able to book, but we are going to annotate the results and tell you, hey, note that Anique just made some, some incentive, $53 or $80, booking the same flight 3 weeks in advance. So we really try to educate you on, what the right behavior is, the way your company defined it. I do want to say that we are leveraging Look to also personalize the incentives, those incentives that would work best for you.
So you've got one more question, kind of a fun one. Why the name Luke?
I'll let Anique, she came up with the name.
I would love to say it was something clever, but it really is just that everyone loves a Luke. And I mean, we talk about machine learning a bunch, so we figured we'd make it a little more human. Elon came up with a more clever explanation, which is that Luke is always looking, but whichever one you prefer.
All right, we've just about run out of time, but we'll follow up with anyone whose questions weren't answered during the webcast. Thank you, everyone, for joining. We really appreciate you being here today, and we'll see you next time.